All right. Um, okay, yeah. So I used to think until the end of last year that there is really no practical reason to use Kotlin over Java. Like if you're starting a new project, yes, Kotlin is definitely better. But if you have an existing one in Java, you already have skilled developers in Java. Well, why switch to Kotlin? So that's what I used to think. Actually, had a discussion with my team about this because we were planning on migrating our project to Kotlin. Now, I think that you should really stick to Java, and you should just switch to Kotlin, if you can, of course. You have stubborn people in the team that will still say, no. But, exactly. But yeah, Kotlin is just better, and I hope to, by the end of this presentation, that I explain the reasons why I changed my mind. So, that's me and my cat. I'm Petrella. I'm a developer for Sytac. I'm also Scrum Master, a chapter lead for this company. I'm a PC gamer, mostly playing Elite Dangerous right now, best player, and I am incoherent, as you may have noticed. So to give you some more context, I do honestly think that coherence is overvalued. Like you should always question your beliefs. Right? You should from time to time think, okay, is what I'm doing the best thing I can do? And how can I go on from there? Another thing to understand is that I used Kotlin only in my personal projects until the beginning of this year. This is important because my personal projects are very different from my professional ones. I use them to learn, I use them to explore cool features, and they generally have a much lower quality because I have less time to dedicate to them. So again, my view from Kotlin was from my personal projects, and of course, conferences, YouTube videos, etc. A small note, I think that Lombok is essential for Java. Like, you shouldn't use Java without Lombok, please don't do that. I know very stubborn people that do that. That's one of those things I cannot concede. Like, I honestly get out of a project if I don't use Lombok because just wasting so much time on useless things. And we're here to have a meetup, to talk to each other, so just raise your hand anytime we have a conversation. So what were my concerns at the end of the last year and how they changed now? Well, my first concern was about the learning curve. Kotlin is, after all, a new language. And if you already have a project going with a team going that's never seen it, there is a learning curve about it. I used to think this learning curve being very steep, again, because in my personal projects I focused on the cool features that Kotlin has in Java class. But by working on it and working it on a real project, that's not really true. You can program in Kotlin using a Java style of programming language. You don't have to use the cool features that were shown. You can just use Java methods and interfaces and let it work. And still you reap a lot of benefits. You still get, better defaults, in my opinion. Kotlin has a few different defaults compared to Java. For instance, Kotlin does power immutability over mutability. So lists by default are immutable, for instance, maps are immutable, etc. It does offer better node checks. And you get all these benefits even if you don't use any advanced feature whatsoever. Another thing that I was concerned with was migration. I have a Java project. I want to migrate it with Kotlin. That can take effort. But in fact, you can just start to drop Kotlin classes into Java code and it will work. Yeah, you have to compile your Maven a little bit, but it's really not that complicated, and I will actually show you later. So again, yeah, you will end up with a project that has some Java classes and some Kotlin classes. Some people might dislike that. But in honesty, I don't see it as a big deal. If you have a project that is running for more than 6 months, chances are that the classes that you wrote at the beginning are very different from the ones that you're writing now. So again, style can be similar. Style would change anyway even if you stick to Java. So even there, my main change a little bit. And the last point I think is also the most important one, and is about feature parity. I used to think that a lot of Kotlin features were more nice to have, and apart from the node checks. and I was like, if we were to try to imagine a set of all features that Java has, that Lombok has, and that Kotlin has, I think it would look more or less something like this. There are very few features that are present in Java and are not in Kotlin, and they are not there for a reason. To my knowledge, you don't have checked exceptions in Kotlin. I agree with that. I never use checked exceptions. I don't think you should use them, but again, I have strong opinions. It's a characteristic of my upbringing. And also with Kotlin, you have a lot of features that you get from Lombok, except a few ones. The one that I miss the most is the field defaults from Lombok, but honestly, I can live without it. That doesn't need to be there, it's just so much. For the rest, you have a lot of stuff that Java just doesn't do, or that you do in some really difficult constructs. And so, yeah, I hope to show you some examples. These examples are available on my GitHub, so you can also check them later. What my purpose will be with these examples to show you some things, how you do them in Java, and how you can achieve the same result in Kotlin. I try to keep it as basic as possible, so that it should be understandable. Even if you've never seen Kotlin, you should see this example and say, yeah, okay, that looks pretty similar to what I'm doing right now. So let's go into it. Right? So let's start with builders. Again, reminder from earlier, you shouldn't do a builder without Lombok. It's like a lot of code for a very simple thing. Again, okay, so we have our person class that just has these three fields, getters and setters. For those fields, I omit them for otherwise it will be too long. Private constructor, and then of course you have a builder method, and then you have the person builder that just takes the things and offers the build. And all this code to then be able to use with very few lines of code and create an object. Now, people that like Kotlin are going to hate me, but you can write a builder in Kotlin in this way. I mean, you shouldn't, I show you, there's much better way to do it. But again, you can write it like this, and this is more or less a one-on-one translation.
You join this up and go. So this is literally the project at my company, the Kotlin project at my company. It's made by a lot of Java developers, and we do everything just like this with Java.
Yeah, so now you can realize how to move forward. But yeah, I mean, you can do this, and you already get some benefits from this, believe it or not. For instance, you can already drop getters and setters because they are implicit in Kotlin. You have this strange thing that's a companion object. In layman terms, it's just how you define static methods and variables in Kotlin. I mean, it might be yours, I might be wrong, but from practical point of view, that's it. And then you can have a builder that just, I made it with an internal constructor, so you can see it from outside. You have to call the builder method to obtain it, and you can use this one to create the person object. And you can mostly call it this way. So you can create the builder object, use the apply method, which is a scope function from Kotlin. And basically what this apply does is a receiver function. Right? The person builder becomes a receiver, so it's this is like if I write this dot in, and I can move that. You still have a fluent interface, but of course this is not a good way to do a builder in Kotlin. A much better way would be to just use data classes. And this looks a lot better, right? You have the same benefits of the builder from Java, but the amount of lines that you need to write a class are more or less the same amount of lines that you need to instantiate. And it's already, it's a small improvement, gives you a lot of features. It encourages better patterns. Of course, we can go a lot more deeper. So, okay, but nobody is crazy enough to build their statically in Java, right? We use Lombok for that. So let's, and Lombok also enables very cool things. I can say I can create this person class again. I can say that's a value, which means that everything inside is private and final, two string methods, =dash codes, etc. And then I can say inside this class that the name is a non-null. So if you've never seen this annotation, non-null in Lombok means that it will throw a runtime exception if the value is not provided when you .build. And this one has a default that is a null. So if you don't pass it, it will just put null there. Null here is probably, I shouldn't have put this because it's implicit. If I just remove this and didn't assign anything, so leave it like that, would have been the same thing, but let's be explicit. Of course, you can do it also with other default values, doesn't have to be that. Hey, yeah, okay, so now I can, oh yeah, and also you have this to-builder annotation here that allows you to duplicate a value object using this field. So okay, now I can create the person Antonio, which is my name, with a date of birth. And then I create my twin, starting from myself, and I say Antonio goes to builder, and I say the name of my twin is Costanzo. I'm Italian, in case you didn't guess. Alright. Okay, so yeah, that's cool. That's a lot better. Like in Java, with Lombok, it's a lot more concise. You save a lot of line of code. The thing is that these features, you still get them also in Kotlin. It's more or less the same code as before, just date of birth and name. They don't have a question mark at the end, which means that they are not nullable. And the date of death, well, has a question mark, because I'm not dead yet, so I don't see why I should put it. And you can do the same thing. So I can create Antonio as a person with a name and a date of birth. And then I create my twin by copying Antonio. So when I do copy, I can specify which fields to overwrite, and it returns a copy of the object with the other value. Of course, this is type safe, this is immutable. This is neither, because it's a feature of a data class. So data classes offer you this copy method, and you're copied the values of that data class. So it's not copy in the sense of Java copy that is defined on all objects. It's in the sense of the feature of the data class that covers. So it's more equivalent to what I did here with the to-builder. So I don't know if it works in the same way, but from a conceptual point of view, it does the same thing. It returns you can only use it on data classes, like you can use the builder on your value objects in Lombok. Well, not on the value objects, but you can only use it on the constructor or static methods. And it returns your copy of that. Now, there is a big advantage here that we don't get with Lombok, and that's the new checks are imposed by the compiler. So if I forget to put a date of birth in the subject, I can forget with Kotlin. The moment I try to compile this code, it will tell me, hey, I expect something for date of birth. With Lombok, I don't get that. I'm going to notice in production, well, probably we tested before, so I'm going to notice in test that it fails and it will throw a runtime exception. So already, with a very simple feature, you really get a lot of benefits. You get a lot of expressivity that you don't get with Java, and also the comparatives. Okay, so this is one thing. I think this is by far one of the most useful features I've seen in Kotlin, like coming from Java. I don't think the web version does. No. So if you have because this is GitHub Dev, which doesn't compile the code. If you were using something like Gitpod, that would show because it would actually compile the code. Of course, if you're using IntelliJ or Visual Studio installed, that would work. That will just now, if If I were doing this with Gitpod, it would be. This is just an editor, so it doesn't try to compile. So this is a very good feature, and I think it's one of the most useful I have, because as a backender, I have to model a lot of data classes. One for the front, one to expose to the front end, one for the database, because I want to avoid the injections and things like that. So every line I can save on those is great, and I love it. All right, so this is about builders. There are other use cases that are pretty common. I think everybody wrote something like this, that you have a class full of static methods that we call utils, and we put the things in them. Like, now, to be clear, I don't like this pattern. Even in Java, I don't use it. I prefer to have a service that does these conversions, and the reasons I find it more maintainable. You have explicit dependencies, etc. But it's something that I see in almost every part of the world. And this is a way, essentially what we're trying to achieve here is to extend the functionality of the person data class by providing a way to return an age. And of course, we could also use extensions to do that. We could create an extended version of person. Don't do that. Extension is really bad pattern. I've seen very few cases in which it's worked. And this is better. If you have to pick between extension and this one, I would pick this one. And okay, so how we can use this? I can just say, okay, person utils.get age, and I say, okay, on person get a call. I defined a new person here directly in Kotlin. That this way, this is what I'm going to use, and I have a static object here called untold, and so I can get. You can already see here that migration is not an issue. I am using a Java object. I'm a Java class, and I'm using a Kotlin object. I don't notice. I have this strange construct where I use a companion object. Maybe there is a way around it, maybe not, but it works, and I can do more or less everything I want with it. Of course, you can see it is here, but if you were to run this code on IntelliJ, it would actually compile. I can do Maven package, and it will work. This is a Maven file. Okay, of course, I can do this in Kotlin as well. I can do it almost in the same way. And if I come from Java, it might feel right to do it this way, that I create a companion object, I do a get page, I do an else here, but before I used the line Java thing, and then I return a period between birth and end.
You know now what's the date of birth, so you need to be person.
No, it's date of death. If date of death is not, I don't know.
Yeah, I mean, if person is alive, you immediately do now with that.
Yes, because I have to take the age, right?
Yeah.
So I'm getting the time between date of birth and now, if they're not dead, or otherwise, keeping it dead. And you can really see something interesting here. Like in Java, you have this ternary operator, like the question mark and the column, to say, okay, if this is true, then do this, otherwise do that. In Kotlin, if else is an operator. So not an operator, don't know the right term, but if it's an expression, value. So it returns a value, which means that I can say end date is equals, well, if date of birth, now, else, that one. Kind of like in Python. I think also in Python you can do something similar, that you say a variable and say if this thing. Cool, and I can use it, okay. And this works, but there is a much better way to do this, which is my second favorite feature from Kotlin after the data classes, and that's extension functions. So what I can do is that I can just extend the behavior of person by saying, hey, a person should really implement a getAge method because I need it. Okay, and then I say, okay, getAge is just a period between date birth, date of death, or else now. But this is called an Elvis operator, and what is it we use this for is to take advantage of the explicit nullability. So date of death, if I go back to person, has this question mark at the end, that means that it's an option. It's nullable. Okay, so when I go here, I can say the between of course, throws a null pointer exception. If you give it something that is null, to say, okay, put inside date of death. This one says what to put in case date of death is null, in which case now, and then just get the years. And so I can use it in a couple of ways. I can either use it implicitly, because it's a companion object, so I can just import the file and say, okay, all right. I can just say, okay, Antonio.getAge, and it will return my age. Or if I like to be more explicit, and I really want to say, hey, I'm using this collection of extensions here, I can use the with function, let's go exactly, and say, okay, using the person utils class, then I can get the getAge. Of course, in this case, it doesn't really matter, but say that you defined this extension inside a service that is using something else as a dependency, right? So it has something that needs to be initialized at runtime. And this method, so this method would only be visible within the scope of that class. And so in that cases, you need to use the with and say with service person.getAge. And I like this better because I really like the this syntax. I really like to see the receiver on the left of things. It's just started programming in C, so you have a variable equals something and the receiver is on the left, and then suddenly I start with Java and a lot of stuff is on the right. That bothers me. I find it a lot hard to read, not to. Okay, cool. So extension functions, I use them a lot. I love them. Probably the high to win wear off. After a while, I start to use them less, but I love them. Now, another thing that I see that bothers me personally, and you might have noticed also something that, what I'm trying to achieve here, showing these examples, is to show how you can be more expressive, how you can write the code that is easy to read, and to get rid of the Java jargon. But again, it's perfectly fine if you just do it in Java style. And I think everybody saw this very bad, very long test names that you say given something, then something else, which I find very, very hard to read because I used to read with spaces and like seeing these very big words, they're kind of, I confuse them in my brain. It's really hard for me to read. And of course, this is hard to do. They actually really test this. Now, this test class has two problems. The first one is that this name is unreadable, and usually they get much longer. And the other problem is that I have this to do that if I forget to implement this test, well, the test will pass. Kotlin offers a fix for both those issues. One is that, well, you can write function names with spaces by using the lefty. And again, these are a lot more readable. I can even put a comma there. So it almost reads like a normal phrase. And speaking dishes.
It's a dishwashing machine.
Nice. All right. And you also have this function that is a to-do function. What this function does is that if the runtime code hits it, it will throw an exception. So that means that if I forget to implement this test, well, the test will not pass. The build will fail, and I know, hey, I forgot my test. And yeah, that's cool. That's also something that you can do in Kotlin. If I were to look how this to-do function is defined, you will notice that it returns the type nothing. It's defined kind of something like this. To do, string, and then it says nothing as a return type. This nothing means that the function returns no result whatsoever. So it's not like the void in Java. It actually expects to return no result. It can only throw exceptions, basically. It's different from Unity. Unity is more similar to the void in Java, so that it's not a meaningful result. Nothing is actually no result. If you enter that function, you're not going to be allowed. It's sensitive to code exception.
Kind of in Java also in terms of code and request implementation.
Wait, sorry, what do you mean?
The name of the method. Because actually environment to this between brackets to the first implementation in Java.
Yes, you can. Yes, you could do that, right? And it has that. That's true. It's an annotation. Yes. I have not seen it really very often. I've seen a lot of this kind of style.
Yeah. Just and file control.
Yeah. And Kotlin gives you this without an extent. Of course, you can still use just test API, the JUnit 5 of that. Sorry, you can use the JUnit 5 framework with Kotlin. You can use everything using Java with Kotlin, more or less.
Well,
Have you also looked at the system URL? I think that for introducing that's great already, but the testing is really making a difference in web. Like in code has test measure, which are with a certain equal, so true, that's more or less what you have. And with this match, you get your test first from what more expensive and also.
Yeah, I want to try that. Unfortunately, because now I'm still working on a project that is half Java Kotlin, we first plan to migrate fully to Kotlin, and then we will explore this.
But it's really something.
Yeah, I saw something about.
Once you've done that, it's like moving Java. You never want to go back to something Kotlin.
Yeah, it's very true. Okay. So one more thing, one more example, and that's logging. Well, can't really improve on logging, right? So you just have, again, with Lombok, you have the SLF4J annotation. It just gives you a log variable that you can use. And then you just say, okay, this is an example, logging for doing some stuff for parentheses, and then you put the things that you want to put there. And same with exception. You do this. All right, that works. That's a way to get laziness in the log messages, at least with this specific library. But you can use something called, for Kotlin, you could use SLF4J. Well, you still use SLF4J, but you could use this style. And you can also use a library called Kotlin logging. You initialize it this way, just you don't have access to Lombok annotations in code. So you have to give up on this. And then you can define the strings using, you can use this other syntax. So you have curly braces here instead of parentheses, which means that it's a function. It's this log input is a higher order function. And inside you can use normal strings. In Kotlin, strings are, you can put templates in string, so that means that I can reference variables directly in the string itself. It's prettier. I like it more. It's easier to read, but you don't have all these parentheses, and then you have to put variable afterwards. And same, of course, with errors. You can do this, and it's a different syntax. So you have when you have when you have a higher order functions that has both non-functional and functional arguments. If the functional argument is at the end, you can have this kind of syntax where the non-functional arguments, you pass them as normal ones, and then you close the parentheses, open the curly braces, and put the text. This is a Kotlin feature, so even if you implement your own method, they are going to look at it. Cool. So this is about logging. Okay, what about doing a sync stuff in Java? Well, one way, so I'm just took the lazy way to do it, which is using completable features. Of course, you can do it in many other ways. You can do it the very old school way if you want to, but for the sake of these examples, completable features are fine. So say that I define two methods that are very expensive and they need to run, in a separate thread, or just I don't want them to block the execution of my code. So I have this runnable that just either throws an exception or not. Then I have an expensive method, takes the next integer, and then I have a next method that squares the integer. So I run them in Java is in this way. There's also a little error handling, right? That you say you create a completable future with your runnable, and then you get the result when you write, when you do it yourself. Or, well, this is with an async, so this will void, or you do a supply, async for the expensive operation, then you apply something else to it. Then I want to apply a log without waiting for it. So as soon as it's done, it will log processing. And okay, so it's not expensive, then I get the result and log the result. Very classical. Now, one thing I hate about compatible future is how you deal with exceptions, because it either throws an interrupted exception, in case it's well interrupted, or it throws an execution exception, which is which the cause is the actual exception that was thrown inside. So yeah, in this case, the cause would be an illegal argument exception, for instance, and so I have to say, okay, if it's an illegal argument exception, then I deal it in a certain way. Otherwise, just generic carry change or however it is. Okay, very ugly, especially if you have a lot of these exceptions and you have to deal with a lot of cases, you kind of break away from this pattern. You have other ways to do it, of course, but this is the like the intuitive way, so to speak. Let's see how a similar case looks like in Kotlin. So here I have a runnable that has the same logic. It's a unit, so it's like a void in Java, doesn't return an input result, just that it's one. I didn't put between curly braces, so I defined this function like the value of this expression. That's just to save on curly, just to show that there is a difference type between things. And again, expensive just gets the next in, next data. Alright. So the way that you do this is you do it with the coroutines. And coroutines are just a syntactical way Kotlin to deal with the non-blocking code. So what I did here, I put this inside a run blocking, which is a scope that you shouldn't use in production, but it's good for examples and for tests. And basically inside this scope, I'm allowed for coroutines. Outside this scope, I cannot. Everything that, if I don't put a run blocking or a coroutine scope, I cannot start calling non-blocking methods, mostly because Kotlin wouldn't know, the JVM wouldn't know how to deal with threads. That's the very short explanation for that. And you have two ways, two standard ways to call the coroutines. You either do the launch, which is similar to the first one here, to the run and sync. So you do that, doesn't return a result. When it finishes the execution, it's a unit. Or you have the async, which is like the other one, so I can actually get a result. So if I do my runnable, I launch it, then I do join, wait for the result. And with the expensive, well, that's a lot better because I can do async. I can call expensive. Then on the result of expensive, I can call next. And then I can log when everything is done. And because it runs inside the async, this will be executed one after the other. And it's a much neater syntax compared to completable features. You just run everything there as a super block with finish. Then when I am ready to get the result, I can just say await, and I will get the result. Now you see that also exception handling is a lot better. Now here I try to also put to make it in parity with what I had in Java, that I also did the generic catch there. Well, not really, but I also had that as with anything to the button. But here, I can either get a cancellation exception, because the thread got cancelled, or I get directly my exceptions, the exceptions that I defined in the code. I don't have to unpack them. Kotlin does that for me. if you in your current project you already have completable features, you actually have an extension library that converts those completable features in coroutine syntax. So you still get unpacked exceptions and everything. And I can just log it. So this again, similar code as that one, but I don't have to do the unpack. And this is a lot easier for in my opinion. It also feels more natural. Completable features and features in Java, they feel a lot like an afterthought. Like you suddenly you break out of the Java syntax and you have to do everything in a fluent way. While in this case, they don't feel like you break your syntax because they are a feature of the language. And they're much more. Well, I like them more because it's more consistent. I think that makes sense. Okay, so this is the very short thing about coroutines. I'm still not so familiar with coroutines yet. It takes some. It's one of those things that I haven't explored much. And but yeah, I see benefits and I started to use them because they do make the code a lot more readable compared to competitive features, in my opinion. Okay.
I think what we use once it's joining and search the conversion, then it's really fall down and you get a synchronizing of other things involved.
Alright, so this is seamless. Okay, now I focused on all those features that Kotlin does better, but what about checked exceptions? I mean, I dislike them, but there is a reason why we have checked exceptions. I mean, the main reason is that if I'm writing a library or if I'm writing some code, I want to make extremely clear what are the possible outcomes of my code. Now, I personally think that you should map those outcomes inside your result of the function, but checked exceptions are there for this reason, so that you have this exceptional scenario. And okay, yeah, so this I just defined a few exceptions, and then I have my dangerous code that can throw an exception and return a string. Well, I have to implement it. And okay, I run it and then I do some try catch. So we try the book job. In Kotlin, we don't have checked exceptions. We have unchecked exceptions. But there are cases in which I might want to do this, to make it explicit to my user that there are some results, some outcomes that are very different from the result that you get. There are many ways to do that. One way is to use sealed interfaces. And so what I do here, I just define an interface for the result of the outcome. I can say, okay, this can either be a coded error, exception, it can be another error, exception, or it can be a success. And the success will contain the actual result. Then when I run my code, it just returns my result. And when I use it, I can just use a when statement, and the when will force me to implement all the branches, unless I put an else. And so in this way, I can say, okay, so I get my value out from the dangerous code, and then say, okay, then it's either a success, and then I can just log the result, or it's a coded error, or it's another. The is keyword is the same as instance of in Java, but it's smart cast. So that means that once you validate with the is keyword, then you can access directly the more specific type. So unlike Java, I don't have to cast out the success because the is keyword already makes sure of that. And this is all compilers. So that means that I'm not doing the weird stuff with reflection, which is the same results. Now this will not compile if I make a mistake. If I update this library and I try to recompile with the new version, it will throw an error saying, hey, you didn't implement this extra case. Again, it's a way to achieve the same result. It's not the same as exceptions because the checked exceptions are not supported, but it's a way to achieve the result. Alright, these are all the examples that I came up with in the previous week. I'm tempted to include more examples as time comes by, because things might be interesting. the last thing I want to show you is, as I mentioned, if you Maven install this code, it will build, and it is both Java and Kotlin, so you have some Java classes. So how you configure Maven for that? Well, it's pretty simple. In general, if you're doing a Kotlin Kotlin project with Maven, you need the Kotlin Maven plugin, and you have to tell the plugin in the configuration part where to find the Java classes, so that they are visible. And then the Kotlin classes are already made available for Java, so this is more for the other way around. On top of that, you also have to tell the Maven compiler to it that it should not do anything with the default compile for the test. Because if you don't override this, it will first build Java without building the Kotlin classes, and then it will tell you, hey, I can't find this Kotlin class. So you have to put none there, and you just say, look, just use the Java compile and the Java test compile. And that's fine. So this will sort everything out because the default ones are defined in the Kotlin mode. So if you first run this, and then you go to Java and Java. Alright, that's all I wanted to show you. I hope it was interesting.